Okay, sorry. So what happens is, when it starts to form covalent bonds, all four of these take on a new identity. Instead of being a, quote, s orbital electron, or p, they become a hybrid. And what was that called? Do you remember that? You probably don't remember that. I only mentioned it once, but if you look right here, when you read this, it'll say the simplest member of the saturated hydrocarbon is the alkanes. As we discussed in 9.1, methane has a tetrahedron structure that can be described in terms of a carbon atom using an sp3 hybrid. Let's try it. So how many s orbitals are there? 1. How many p orbitals are there? 3. So all four of these electrons, instead of being an s or a p orbital, they take on not that energy level, not this one, but one in between. We know what hybrid means? Kind of like half and half, you know? And so each of them will now take on the, they're going to be called sp3 orbital, which is a new, or it's like a halfway between, isn't it? And so that's what allows carbon to form 4 separate bonds with things. And so that's what that is right there. Okay, and we talked about the tetrahedron. Now, I want to mention something about, we know what isomers are, right? We're going to spend a lot of time with isomers. Let's see, we're going to talk about that too. Let's see, I'm looking for things we haven't talked about yet. Did I talk about this yet in physics, the kinetic energy equation? Have we talked about that at all? There was a little bit of that last chapter. Why is it that really big molecules, why do you have to heat them more to get them to turn to a gas? Why are their boiling points so much higher? Little molecules, you can put a little bit of heat on them, and they like to boil away. What do you think, Tim?
Because they're more massive.
What does that mean?
They have more mass.
Well, I know that.
There are
I mean,
more molecules, there are more atoms a part of the molecule.
I know, but what does that have to do with why you have to heat them more to get them to boil?
Because,
Yes. All right, go ahead.
More massive things need more kinetic energy in order to...
Who said that?
I don't know.
This equation does. So what is the relationship between kinetic energy and mass? So if you had two particles that had the same velocity, a little guy, a little massive guy, and a big guy, and they had the same speed, what would that mean? If they had the same speed, then the one that had more mass would have more kinetic energy. Let's try this again now. Let's say you have a certain mass, and the little guy, I have to get up to a certain speed to turn into a gas. So how much was going to take me? How much energy is it going to take me to jump his speed up? So what it really means is that if you're a big molecule, it takes more energy to get your velocity up high enough to change from a liquid to a gas. So that's what this chart shows right here. These are all alkanes, aren't they? And they're all nonpolar. Because remember, if you only have carbon and hydrogen, you're going to be nonpolar. So don't have to worry about hydrogen bonding, right? And so look what happens. Look at the boiling points. I'm a little guy, and I boil at minus 162 Celsius. That's like cold, isn't it? I boil when it's cold. And then as they get more massive, notice it takes a higher temperature. And the reason I like that chart is we don't have to worry about hydrogen bonding. If they were hydrogen bonding, they would boil at a much higher temperature than you would expect. So we're getting a little more detail in there. All right, let's go to the thing. Does everybody have this little chart, that little packet I gave them yesterday? We're going to start. I think this is when the bell rang, so I'm going to go ahead and start right there. Now I'm going to refer to the book also, so I'm going to leave that open. Now, regardless of what they called them in the last packet, yes, all the alkanes are still what they are. But when we start naming isomers, chemists said, hey, wait a minute, we can't just say iso and neo. That's not going to work. There's too many isomers. So they said we have to have a system of naming these isomers that really works. Okay, everybody ready? So here we go. the first thing you're going to do is look for the longest chain of carbon atoms. What's the longest straight chain? And when I say straight, they can be bent. Okay? What's the longest chain of carbons I can get? And this is when the bell rang yesterday. So let's look at this guy here. Now, last chapter, part 1, here's what you would have called this. What would you have called this chemical? You would have said, well, it's all single bonds, so I know it's ane. And you would have said 1, 2, 3, 4, 5, 6, 7. And you would have said heptane. Is that correct? You would have said heptane because it's it's C7, H2N plus 2. Is that correct? Now, we have to learn a sort of a new way of naming it, okay? It is true that it is an isomer of heptane. That is true. But how are we going to name this isomer? And here's what we do. The longest chain I can find, 1, 2, 3, 4, 5, 6. There's only 6. That's the longest chain I can find. So I have to call it hexane. Now, I know that bothers you because you know it's heptane. But here's what we got to talk about. The last thing out of my mouth is hexane. Now, next, I have to find out whether it has a branch. And does it have a branch? Is that correct? So it does have a branch. What do you call a branch that's made of CH3? If methane is CH4, what's a branch that's a CH3 branch? Methyl. Okay, so here we go. Now, this is going to be called methyl hexane. Now, if you think about it, there's 6 carbons, and there's the 7th. See? There are 7 carbons there, right? Now, here's my problem. Not my problem, your problem. Is that the only way you could make methyl hexane? No. I could have put the branch here, couldn't I? So if there's more than one way of doing it, I don't want to be confusing, do I? So what they do is, you find the branch. What's the lowest possible number you can use to tell me where the branch is? So let's try it. What if I start from this end? Ready? Carbon 1, 2, 3, 4. I could say your branch is on carbon number 4, couldn't I? How else could I say it? Let's go the other way. 1, 2, 3. The branch is on number 3. What's the lowest number? 3. So, what are they going to call it? Which methyl hexane? 3 methyl hexane. What am I telling you? I'm telling you that the methyl group is on which carbon? The 3rd carbon. Yes? Okay.
Couldn't you potentially reduce it even more since there's only 2 isomers of that? There's
Okay, be careful about the word isomers. What you mean is there's only 2 methyl hexane isomers. We actually can have some other isomers that are not hexane. How about pentane? So that's what we're dealing with. The next phase of organic chemistry, we're going to do, instead of model building, we're going to do whiteboarding. I'm going to have you get the whiteboards out today, and we're going to try some of that, where you try to tell me what the isomers would look like, and then we try to name the isomers. Yes?
Couldn't you just say like 1 or 2 since there's only 2 variables?
Well, okay. If I could show you, when we do octane, we're going to have 18 isomers. If I don't have a naming system that can take care of all 18 of those, then it's not a very good naming system. So I know what you're saying. In this case, there's only 2 methyl hexanes. Why don't you just call them number 1 and number 2? Because later you're going to have something that might be 2,3 dimethyl. And said, what do you mean 2,3? I'm on the 2nd and on the 3rd carbon. All right, yes, Carson.
So just like for clarification, you couldn't move like the branch to one of the ends?
Okay, excellent question. Now remember, a branch can never come at the end. See, if I were to bend this, I can bend it. That's not a branch. You can never have a branch on the end of a carbon, can you? So now, I could make another one. What you're saying is there another way I could have had a methyl branch? Yes. But here's what you have to think, and this is what I like about this thing. It makes you think a lot. What if I put it here? Is that different?
You just spin them around.
It's not. You know why?
So,
Because if I come from this direction, it'd be called 3-methylhexane. So putting that here is the same as putting it here. But what if I put it here? Would that be different? That would be called what? 2-methylhexane. Yeah, Carson.
I'm confused because, I mean, if you move that over to like the end one, and you count up like the longest chain.
Okay, now, good question. If I push this over here, then what's the longest chain of carbons I can have? 7. And they call that N-heptane. Now, N means that everything's in a straight chain. You get that? N-heptane, if I put this guy over here, I have 7 in a row. I have 7, no branches. You can't have a branch on the end. So if I put that guy right there, then my longest parent chain is 7 in a row, and is a straight chain. I'm going to call you N-heptane. N-heptane. Now, if we just do a few more of these, you'll see how this is going to take some thinking. And I like that. I like that part of this class. All right, here we go. Look at this guy right here. And I want you to find the longest chain of carbons that you can. So you have to try it this way. You try it this way. Excuse me. It's kind of fun. Once you start doing this, I'll get you in groups here pretty soon, and we'll be doing it. You say, "Hal, I'll try this way." 1, 2, 3, 4. Is that it? 1, 2. Is that it? No, let's start up here. 1, 2, 3, 4. That's only 4. 1, 2, 3, 4, 5, 6. What about that? Or 1, 2, 3, 4, 5, 6. It doesn't matter. It won't matter which one you pick. You give me the 6 in a row, and I'll tell you what to do with it, all right? Does everybody agree that the longest chain is 6? Now, you don't have to do this, but here's what I like doing. I like circling the parent chain. And then guess what? What's the only thing that's not in my circle? What are they called? Starts with a B. Branches. All right, so here we go. Last thing out of my mouth is what? Hexane. We're going to name this backwards, aren't we? Now, do you have any branches? Well, there's a branch. What's that called? Methyl. What's that? Methyl. You got 2 methyls? How are you going to say 2 methyls? Dimethyl. Now, you're not done yet, because is that the only way you could have made dimethyl? And this is going to take some thinking, okay? I have one here, and I have one here, couldn't I? What if I put one here and one here? What if I put them on the same carbon? Oh, since there's more than one way to have dimethyl, I've got to tell you which one this is. So how do we number it? Let's try it. If I go this way, 1, 2, 3, 4, 5. 4, 5 dimethyl. Let's go the other way. 1, 2, 3, 2, 3 dimethyl. Which one's the lowest set of numbers? Oh, that's what I'm going to call it then. Ooh, we're getting pretty fancy here, aren't we? Getting fancy here, right? So what's the name of this? 2,3 dimethyl hexane. Again, what would you have called this last chapter? You would have called it octane, right? Okay. What do you think? We're just getting started, and I'm going to get you in groups in a minute. Let's do the next one. See if you can do the next one. And yeah, it takes a little time to figure out what is the longest parent chain. All right. Who wants to take a chance and said, I'll tell you what I think it is, and it's okay if you don't get it right. I'm okay with it. All right, Calvin, what do you think? What's your parent chain, first of all?
Pentane.
So you thought it was 5?
Yeah.
Now, did you know that if I go this way and get my 5, will I get the same answer as if I'd gone this way? Yes. That's what's interesting. If you thought this was 5, you'll still get the same answer. That doesn't seem right, does it? All right, go ahead, Calvin. What do you say it was?
Pentane.
Pentane, right?
Yeah.
Now, you got any branches?
Yeah.
What do you got?
Dimethyl.
Okay, dimethyl.
And then branches 2 and 3.
Yes. What do you think about that? Does everybody think that's right? 2,3, dimethyl, pentane. All right, let's try the next one. All right, Caroline, your turn. What's your longest parent chain?
Pentane.
5. Did you go this way? 1, 2, 3, 4, 5.
Yes.
What if you had gone 1, 2, 3, 4, 5?
The same.
You would still get the same answer. I know you don't think so. So did you do this one? Is that the one you did? All right. All right. What is it? What's the last thing out of your mouth?
Pentane.
Okay. What do you got? Any branches?
It does. Wasn't exactly sure how to do that because there's two.
We haven't talked about that really, have we? What are the 2 branches though?
There's a methyl and then there's another
And that's this. What's the name of that kind of a branch with 2 carbons on it?
ethyl.
Ah. So we got a methyl ethyl. So now what? Now we got a methyl ethyl. Now, chemists had to figure this out, and I'm not trying to say I'm not an organic chemist, and there are millions of organic compounds, but what they did is we have to number these branches. So this branch is, are you going to number it 3, 4? There's a branch on the 3rd carbon and the 4th, or are you going to go the other way and say there's a branch on the 2 and the 3?
2, 3.
I do. So I'm going to call it 2, 3, but 2, your first one was what kind of branch?
Methyl.
Okay, so in this case, I'm going to have to say 2-methyl, 2-methyl, comma, what?
3-ethyl.
3-ethyl, pentane. What do you think about that? Yes?
What would you have done if you made the corner?
Okay, now here's what would happen. Great question. Let's pretend that this is my parent chain.
The other way around. Other way. The other corner.
The other corner. Oh, you want to go this way?
You
No.
can't start on the left to make the corner.
Oh, okay, I got you. Oh, all right. That's really good thinking. Now, I will say there are some times where, even though they have this rule doing it, that one makes something kind of different. It is true. I can tell you what this is, but I agree with you. It's actually not quite the same name, is it? And I got to think about why. Yeah, that's not a good idea. I'll tell you what this is in a minute, okay? But that's a great question you had. Most of the time, regardless of which way you go, you get the same name. This is one of those things that looks kind of weird. If you don't mind, can I come back to that when I show you what the name of that branch is? Okay, so hang on to your hats. We do know would be a name right there. Now, one thing I haven't mentioned to you is, what if I put the methyl branch on the same carbon as the ethyl branch? Now, what happens there is, if they're on the same one, then they like to use alphabetical order. So they would say to ethyl to methyl. You get that? Or they could go 2,2-ethyl methyl. But I don't have to do an alphabetical order if they're on different carbons. But if they happen to be on the same carbon, you got two different branches on there, they usually like to keep that alphabetical. Okay, so there are some things that are kind of weird. Calvin, that's good that you picked up on that, because I'm going to show you, as soon as we finish with that, I'll show you some branches, and then we'll come back to that, okay? Let's do the next one. Let's see, Alex, what do you think the longest parent chain would be here?
Did you pull the paper?
What? I'm sorry.
Paper.
Okay. Okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And again, I don't really care which way you go, but it's going to be heptane, right? Do you have any branches? 3? What kind of branches? So is that methyl? Dimethyl? Trimethyl? Oh, man. Trimethyl. Now, is that the only way you could have trimethyl heptane? Or could I do one here, one here, one here? Oh, well, if there's more than one way to do trimethyl, you got to tell me the numbers, okay? So which way you want to number it? 2, 3. Say it again? 2, 3. That's only 2 of the methyls. You got to tell me all 3 of them are. Say it again? 2, 2, 3. One more time? 2, 2, 3. Yes. 2, 2, 3 trimethyl heptane. Does that make sense? That's kind of neat. This kind of, when we start doing all these isomers, I think you'll enjoy this. All right, let's do another one. Let's see. I'll tell you what. Let's not do that for. You can finish these. They're kind of like the same thing we've been doing. We started this yesterday, and I talked about this right here. There's only one way to be a methyl group, isn't that right? That's easy. How many ways can you be an ethyl group? That's it. How many ways can you be a propyl group? I could do all 3 in a row, or I could do, Okay, so a real important page for you is page 1000. Excuse me. Let's go to page 1000. All right, here we go. I won't have any more than these. This is about as far as I'm going to go, but how many different ways can you have methyl? Just one. How many ways can you do an ethyl branch? Just one. How many ways can you do a propyl branch? Yeah, Carson.
Well, I had a question on the first one.
Okay.
Like number 2 that we did on the packet.
Uh-huh.
Why is it like 3-methylhexane instead of like propyl?
Okay. You're talking about this one?
Number 2, it's at the top.
Oh, at the top. Oh, this one?
To the
Are you
right.
talking about the branch?
Yeah, the very first example we did.
This one?
No, to the right.
This
The
one?
big-
Oh, you mean this?
Yeah.
Okay. So what's the longest parent chain I could come up with? How many carbons?
6.
Okay, so I'm going to kind of circle those so you don't look at them anymore. So I know it's a hexane. And what's the only thing left?
Oh, okay. I was just thinking.
But we are going to have some propyl branches in a minute. So take a look here. How many ways can you be a propyl branch? Well, boom, 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 boom. 3 in a row. I'll call you propyl. Thank you. Thank you for not making a weird name. Let's call it propyl. But I got to come up with another name, and here's that old term, isopropyl. Get it? So if you're the forked propyl one, you're isopropyl. You all right? And there's only 2 of them, so I think I got that. Now, butyl. How many ways can you make a butyl branch? 4 in a row. What are you going to call that? Butyl? Thank you. So if it's 4 in a row, it's called a butyl branch. Get it? But what if you have not on the first carbon not the first carbon and 4 in a row, what if you attach to the second carbon of those 4 in a row? And I would draw it this way. What if you had 4 carbons, but you attach to the second one, then you got a little fork here, don't you? And this is the one I have trouble remembering. It's called sec-butyl. But I'll tell you why they call it sec-butyl. Because he's not attached to the first carbon, he's attached to the second one, isn't he? So it's sec-butyl, like secondary. Now, here's another one. What if I have this like a Y-shaped thing? This Y-shaped butyl. That's isobutyl. And then my favorite one is tert-butyl. And does anybody know what tert-butyl means? What do you think tert means? What is it? Third. That's right. And so in this case, this branch has a carbon that has 3 other carbons attached to it, doesn't it? Whereas this carbon has this carbon has 2 different carbons attached to it. So this is tert-butyl. The reason I like this one is it kind of makes a T shape. See how it makes a T shape? So that's how I remember tert-butyl, that one. Okay, so now we have some names. Let's go to, let's see here. Let's go to the book. Let's go to the book. Let me see here. The names of alkanes beyond butane are obtained by adding the suffix -ane. We already know that. Okay. Find the longest continuous chain of carbon atoms to determine the root name. And so if you take a look at this one, you can. Here's where it gets interesting when you start doing isomers. You have to be careful because you might say, "Oh, I know what this is. This is ethane with some huge branch on it." Now you can't do that. You got to say, "What's the longest continuous number of carbons I can get?" And I can go this way: 1, 2, 3, 4, 5, 6. I can do it that way: 1, 2, 3, 4, 5, 6. Everybody see that? There's hexane, and what is this called? What's that branch called? Ethyl. Now, is that the only way you could have ethyl hexane? And by the way, you can't put him on the end. Do you get that? That can't be a branch. Branches aren't at the ends. I can't put you there, and I cannot put you there. What if I put you here? Is that different? Look at your faces. If I had, right now I have 2 going this way and 3 going that way, don't I? What if I put you here, then what happens? I have 2 going that way, and so what do you think? Is there another way to do ethyl hexane? Now, I'm not going to, I would say to be safe, just put the number anyway, but normally, if there's only one way to do it, right? If there's only one way to do it, they normally don't say the number. Yes?
Doesn't that be a straight chain still? But if you put the ethyl group on that top,
Here?
yeah, that would.
That would be, the longest parent chain would be 8.
Okay.
That'd be called N-octane. N-octane. Yes?
Does the kind of like number of ways you can have a group, does that follow a Fibonacci pattern?
No, even though, did you say Fibonacci?
Yeah.
Okay. Even though Fibonacci is found a lot of times in nature and different things, I've never heard anybody relate, and I'm not a mathematician, but I've never heard anybody write an article and said that the Fibonacci sequence has to do with isomers. I've talked about pine cones and things in a flower. I've heard of that. I've never heard it linked to this.
It goes 2-2, doesn't it?
What now?
The Fibonacci pattern goes 2-2.
What do you mean 2-2? What's that mean?
Like, isn't
Isn't it-
pattern like
Isn't it? Don't you add the number before to it? Like you have 1,
Yeah.
and then you have 2 plus 1, and then you have 3 plus 2 plus 1.
uh,
I think it's Fibonacci. I think.
Yeah.
But anyway, so in this case, I would go ahead and put the number anyway. But if you're an organic chemist, they'd say, "What? Why did you say 3? Why do you say 3 ethyl hexane? That's the only way you can have ethyl hexane." But since you're not an organic chemist, I'd go ahead and say 3 ethyl hexane. All right, does that make sense? All right. Now, let's do this one. Oh, I have the answer. Don't look. What do you think about that one? This is pretty easy, isn't it? Do I need a number or not? To be safe, I put the number in there anyway, okay? But I do need a number because how many ways can you make methylhexane? Now, what you're going to find interesting, I think, is when we start building isomers and making them, you're going to see that there is a limit. Like, for example, if you start having a branch that's like 4 long, and all of a sudden the branch is 4, and your parent chain is 4, you made a mistake. Because, anyway, so it's not like we have unlimited number of isomers. All right, so this, what I'm going to show you, I'd like to start out with baby steps. And so what I'm going to ask you to do is we're going to try to write, and for right now, we'll do, I'm not sure I'm going to get whiteboards out today. We'll see. Maybe. Let's do methane. And how many isomers are there of methane? Okay. And so he said, you know what? I think we're done. And there we go. I won't draw the hydrogens in there. So how many isomers of methane are there? 1. Yep. Let's do ethane.
Could you scoot the paper down?
Oh, yeah. Okay. Let's do ethane. And again, if we just draw the carbon backbones, it takes a whole lot less time, okay? How many? 1. Oh, let's do propane. Okay, now, since there's only 1, I don't have to use the word N because there's only 1 of them, right? So if you say propane, everybody in the world knows you mean that one, isn't it? And by the way, there are no more isomers than that. Okay, try this one. Now it gets much more complicated, so if you think you're falling asleep on this, it gets a lot more complicated. Could I have 4 in a row? Are there any other way to do 4 in a row? Some of you might be saying, ring structure. No. You pay a price for a ring structure, don't you? What is that? You know. That can't be an isomer then. It's wrong. It doesn't have the same formula, does it? No ring structure here. Now what? Is there another way to do this though?
We're gonna do a 4 straight curve.
I don't have any more of a 4 in a row, but what if I did 3 in a row and a branch? Can you put a branch here? 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 Okay. So now we gotta name them, don't we? I hereby declare your name is N-butane. You're the straight chain, the kind of the normal. I don't like that word normal, but you're the straight chain butane. And now you can't call this butane like you did last chapter. And we're not going to call it isobutane either. What are we going to call it? Methyl propane. And I really don't need the number because is there any other way to make methyl propane? If you want to put the number in, but it'd be kind of silly because there's only one way to do it. Now, do you understand it's getting more complicated? Let's do the next one. All right, you try it. Now this is the last one I'm going to have you do by yourself. And then when you go on beyond this, I'm going to have you sit with people. Because you have to talk it out. All right. Let me ask you this. How many people think that there's only one? How many people think there are two? Only two. How many people think there are three? How many think it says more than three? Okay, well, the good news is not only was this in the last packet, it was on the test twice. And so, what are they? 2, 3, 4, 5. There's that one. There are no more. There are 5 in a row. Let's go down to 4 in a row. Now, where are you going to put the branch? I can't put it here. I can't put it here. You want to put it here? Okay. Now, this is butane. This is methylbutane, right? Is that the only way you can make methylbutane? Think about it. What if I put it up here? No, same thing. What if I put it over here? No, same one. What if I put it here? No, no. Are you done with the 4 in a row? Yes, you are. You are done with the butanes. Now what? So some of you probably remember that from the test, right? All right, so now we name them the new way, all right? The big boy and girl way of naming them. What's the first one? Who wants to take a chance on the first one? All right, what is it? N? Pentane. All right, I like that one. All right, next one. All right, Tim. Methyl what?
Or butane.
Wait, you had me going there for a while. Are you going to use a number?
Yeah, there's only one way to do it.
Right. So in this case, you probably would never see that. You'd never see 2-methylbutane because that's the only way you can make methylbutane. All right. Next one, Gabby Black. What is it?
Dimethylpropane.
Right. All right. In this case, do you need numbers on this? The only way you could have dimethylpropane is this way, isn't it? So you wouldn't see numbers on that one. All right, here we go. Now, I want you to go sit with somebody, and this will challenge you, okay? Can I tell you something? You will be challenged on the next one and the next one. I want you to find out as many isomers as you can do and put their name on it, okay? By the way, this one had 3. So 1, 1, 1, 2, 3. Again, no Fibonacci here. All right. All right, sit with somebody and see if you can come up with, and I'll come around the room and I'll say, how many people think that there's only 1, 2, 3? You could have 3 people in a group if you just want to move around here, or you can sit anywhere you want. I bet you got the first one done already, don't you? And by the way, when you name them, if you have the same name, you'll know that that was the same isomer, and you can get rid of that one. If you're not sure if it's a different one, then name it. If you try to name it and they have the same name, you'll know that they're identical.
then if you did one with the same one. So it would be 2, 2. Oh, you're right.
All right, real quickly, just stop what you're doing for a minute. How many people think there's only one? How about 2, 3, 4? Anybody have more than 4? 5? Anybody have more than 5? Anybody have more than 5? You do? How many do you have? 6. He think there's 6. If you thought there was 5, go back and check.
Or is it dimethyl?
All right, let's go again. How many people think there are only 4? How many people think there are 5? How many people think there's more than 5? Ooh, look, you got some new converts over here. How many people think there's more than 6? So you're going with 6, right? 6, 6, 6. What are you going with as your final answer? What? Are you gonna stay? Are you gonna stand up to only 5? Wait a minute. All right, wait a minute. Wait, we're running out of time. I gotta tell you the answer, okay? You can go home and redo this, but I have it in the book here. It says there are 5. Now, if you got 6, what happened is, if you'll name them, you should have had 2 of them with the same name. All right, thank you very much. You gotta go now. Sorry. Tomorrow, we're gonna get in whiteboard groups and do heptane. Heptane.